Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P050A indicates a cold start idle air control system performance problem specifically in the Honda HRV models from 2016 to 2022. This issue typically arises from components involved in the vehicle's idle air control system, which plays a critical role in maintaining smooth engine idling, especially during cold starts. The system relies on sensors that monitor various environmental conditions and send this data to the Powertrain Control Module, PCM, to adjust the air-fuel mixture accordingly. When the engine is cold, the air control valve should allow more air to assist with starting the engine smoothly. Locating the components can be crucial. The throttle body is situated between the air intake duct and the intake manifold, allowing air to flow into the engine. If the system malfunctions, it can lead to various performance issues, including idle instability, poor fuel efficiency, or stalling during cold conditions. Understanding this DTC is important for diagnosing and resolving idle-related issues effectively. DTC P050A signifies that there is a performance problem with the cold start idle air control system. This system is integral for controlling the amount of air delivered to the engine during startup, particularly when the engine is cold. Essential components involved include the throttle body and the sensors that monitor engine conditions. The throttle body controls airflow, and the PCM analyzes feedback from sensors to adjust the idle speed. The issue occurs when there's a deviation in performance, which can cause poor idling. The components are located in the intake system. For instance, the throttle body is situated right after the intake air duct, allowing air to flow into the engine. Recognizing how these parts work together is essential for proper diagnostics and troubleshooting. Several potential causes could lead to the DTC P050A being triggered. First, poor connections or blockages in the intake duct could obstruct airflow to the engine, leading to an imbalance that affects idle performance. Second, if the air cleaner housing is faulty, it might fail to filter airflow properly, influencing engine performance during cold starts. Additionally, a dirty air cleaner element can severely restrict airflow, making it difficult for the system to maintain adequate air supply for smooth idling. Regular checks for these conditions are crucial, as they can often be remedied with simple repairs or replacements. Each of these causes directly influences the vehicle's ability to manage cold starts effectively, making timely diagnosis and rectification crucial. Symptoms associated with DTC P050A can significantly impact the vehicle's performance. A common symptom is rough idling, which indicates that the engine is struggling to maintain a steady RPM while in idle mode. This often results in stalling during cold starts, as the engine may not receive the proper air-fuel mixture necessary for smooth operation. Drivers may also notice poor fuel efficiency due to improper air control, leading to an incorrect air-fuel ratio that wastes fuel. Additionally, increased engine noise may be observed, as the engine works harder to compensate for the inadequate air supply. Each of these symptoms can make driving uncomfortable and may worsen if not addressed promptly, making it imperative to troubleshoot this DTC efficiently. The first step in troubleshooting DTC P050A involves verifying the current condition of the vehicle's onboard diagnostics. Begin by turning the ignition to the on mode while ensuring not to start the engine. Once in this state, connect the HDS, or Honda Diagnostic System, to the vehicle's data link connector to check for any pending or confirmed DTCs. It is vital to assess if there are any other DTCs present, aside from P050A. as these could indicate related issues that must be addressed first. If any other DTCs are confirmed, the troubleshooting should pivot to those codes. Conversely, if only P050A appears, the process can continue to the next step. Collecting this data is crucial to understanding the vehicle's precise issues and correlating them effectively to the symptoms. The second troubleshooting step requires a visual inspection of the intake air duct. This duct is essential for channeling air into the engine and subsequently plays a key role in the cold start process. Begin by examining it for any signs of blockages that may hinder airflow or poor connections that could affect the integrity of the system. If any faults are identified, immediate repair or reconnection of the duct is necessary to ensure proper airflow. If the duct appears to be in good condition, the diagnostics can proceed to the next step. This step is crucial because unobstructed airflow is essential for optimal engine performance, especially during cold starts. In troubleshooting step 3, we focus on the air cleaner housing, an important component that determines the cleanliness of the air entering the engine. Begin with a thorough visual inspection to ensure that there are no blockages or significant flaws in the housing that could impede airflow. The air cleaner housing must maintain a secure connection to facilitate proper filtering of air as it enters the engine. If any discrepancies or blockages are identified during the inspection, replacing the air cleaner housing may be necessary. However, if it appears to be intact and functioning correctly, the troubleshooting can advance to the next step. This step is necessary because a clean and unobstructed air supply is vital for maintaining engine efficiency during operation. Step 4 in troubleshooting involves examining the air cleaner element, which plays a fundamental role in filtering the air entering the engine. A dirty or obstructed air cleaner element can significantly limit airflow, directly impacting engine performance, especially during start conditions. Conduct a detailed inspection for dirt, dust, or any debris that may be present on the element. If the air cleaner element is dirty, replacement is the appropriate course of action to restore optimal airflow and functionality. However, if it is found to be clean, proceed to the next step. Ensuring the air cleaner element is in excellent condition is crucial because it can directly influence fuel efficiency and engine performance. In the fifth step of troubleshooting, ensure that the engine is cooled down to a temperature of 122 degrees Fahrenheit, 50 degrees Celsius or less. This ensures that the test conditions are suitable for verifying the issue at hand. Once the engine has reached the desired temperature, utilize the HDS to clear the P050A DTC. Following this, start the engine and maintain idling for at least 10 seconds while observing the onboard diagnostics (OBD) status for DTC P050A. This process will provide insights into whether the issue persists after the attempts to address previous potential causes. If the HDS indicates a failed status, it confirms that the issue still exists, prompting further troubleshooting steps. Conversely, a passed status would suggest that although there could have been an intermittent issue, the system appears to be functioning correctly at the present time. The sixth step involves testing the throttle body through the Electronic Throttle Control System (ETCS) test found in the HDS. The throttle actuator control valve within the throttle body regulates the air intake into the engine, and its performance is critical for both idle control and overall engine operation. Upon selecting this test, the HDS will provide necessary information on whether the throttle actuator is functioning normally. If the test indicates that the throttle actuator control valve is not working correctly, the recommendation is to replace the entire throttle body. This step is essential, as a faulty throttle body can create significant issues, including poor idle performance and undesired engine behavior, particularly during cold starts. In Step 7, the focus shifts to the mass airflow MAF sensor performance check. Begin by starting the engine and revving it to a steady speed of 3,000 RPM without any load. Holding this RPM allows for a consistent airflow reading, which is then monitored before letting the engine return to idle. Keeping an eye on the MAF sensor parameters during this process is essential, as it reflects the amount of air entering the engine. The HDS will display these readings, allowing one to compare them against established thresholds. If the current conditions meet the required thresholds, the MAF sensor is deemed satisfactory. However, if they don't align, it indicates a failure, warranting a replacement of either the MAF sensor or the intake air temperature IAT sensor, as both components are pivotal for correct air-fuel ratio management. The final troubleshooting step focuses on the intake air temperature IAT sensor, which plays a crucial role in measuring the temperature of the air entering the engine. Begin by switching the vehicle to off/lock mode and allowing the engine to cool to ambient temperature. Next, note the ambient temperature before turning the vehicle back to on mode to observe the IAT sensor value from the HDS data list. Compare this value against the noted ambient temperature. The difference should not exceed 5.4 degrees Fahrenheit, 3 degrees Celsius. If there is a significant disparity, replacement of the MAF or IAT sensor becomes necessary, as this would indicate improper sensor performance, which directly affects the vehicle's cold start efficiency. If the IAT sensor value aligns closely with ambient conditions, proceed to inspect the throttle body for any dirt, carbon buildup, or potential damage, thus ensuring the overall integrity and effectiveness of the air intake system. Final repair verification is an essential step to confirm that all repairs have been successfully completed regarding the DTC P050A. After making necessary replacements and repairs throughout the troubleshooting process, it is crucial to use the HDS once more to check the DTC status. The goal is to ensure that no pending or confirmed codes, particularly P050A, are present, indicating the concern has been adequately addressed. Additionally, take a moment to observe the vehicle's idle performance during a test drive under various conditions, particularly during cold starts, which previously exhibited issues. Proper idle performance signifies that the system is now operating effectively. This verification plays a significant part in ensuring long-term vehicle reliability and customer satisfaction. Preventive maintenance is key in avoiding future occurrences of DTC P050A and in ensuring the longevity of the vehicle's specific components involved in the cold start idle system. Regular inspections of the air cleaner are vital. A clean air cleaner helps maintain optimal airflow and performance levels. Additionally, keeping an eye on the condition of the throttle body is critical, as this component directly influences air intake and idle performance. Periodically checking the performance of both the MAF and IAT sensors can preemptively identify issues that could lead to a failure in the cold start performance. Establishing a routine maintenance schedule for these components will help ensure both the driver comfort and engine efficiency, ultimately extending the vehicle's operational lifespan. In concluding the troubleshooting process for DTC P050A, understanding the nature of this code is paramount before diving into diagnostics. The systematic approach outlined ensures that all potential causes and symptoms associated with the cold start idle air control system are addressed. Correctly identifying and rectifying issues, such as blockages, poor connections, or faulty sensors, leads to improved engine performance and efficiency. Additionally, conducting regular maintenance checks will greatly reduce the likelihood of similar DTCs appearing in the future. This proactive approach not only enhances vehicle reliability, but also contributes to optimal performance, making for a smoother driving experience. Please like and subscribe to the channel. See you next time!